vertical asymptotes are found where the denominator becomes 0 and you can't cancel that problem term. So here's what I mean. If we would factor the top, we would get x minus 3 times x plus 3. And the bottom would factor into x minus 3 and x plus 1. Now, the x minus 3 and the x minus 3 can cancel. We still have a problem at x equals 3 because if you plug it in, you get 0 on the bottom. But what happens at x equals 3 is it leaves a hole in the graph. And your question isn't asking about holes, so we'll just leave that for now. The simplified function, which is now x plus 3 over x plus 1, because we could not cancel the x plus 1, if x were to equal -1, we would be dividing by 0, and that's not okay. So this is the equation of our vertical asymptote. We're never, ever going to be allowed to use x equals -1. Now, in terms of horizontal asymptotes, this is sometimes called end behavior. And the end behavior is what you get when you go all the way to plus infinity or all the way to minus infinity. And since at plus infinity, this is infinity plus 3. And when you have a number as huge as infinity, the plus 3 just doesn't matter. And on the bottom, we would have infinity plus 1. And again, with a number as big as infinity, the plus 1 doesn't matter. So this is some huge number divided by itself. And so that equals 1. It would be the same if these were negative. And so this is where our horizontal asymptote is. And I have graphed these on the next board. I put the original function in because I want you to see that it really works. So let's go to board 2. Notice we have a vertical asymptote here at -1. We should have a hole in the graph here, but you weren't being asked about that. But we also have a horizontal asymptote. We'll make it purple. And if I would draw it here at 1, it would fit the picture. So our vertical asymptote is at x equals -1, because that's what makes the denominator 0. Our horizontal asymptote is at x equals 1, because that's what this graph is going to flatten out to, that y value, that y equals 1. When you go to plus infinity, the blue line, it flattens out to almost equaling y equals 1. And on the left, as you go to negative infinity, as you go here, as you go out this way, it's going to flatten out and almost equal y equals 1, but never quite reach it. So this is what the graph looks like. And this is our horizontal asymptote at y equals 1. And this is our vertical asymptote here at x equals -1.